In this video, what we're going to do is we are going to create multiple training definitions and run it in one experiment, and then we get to actually compare the results. The first one, we're going to get started with removing the con-D and the pool-D layers from the default architecture. So you're going to get an understanding of the impact or the benefit the pooling and the convolution layer brings to the table. Then we will increase the epochs of the default architecture, because we know that the default architecture is going in the right direction. So the weights are converging and you get a nice 0.9 accuracy. Of course, this accuracy will change, or at least is bound to change in your next runs, and you really can't say what the accuracy is going to be. Of course, it's not going to be too bad. It's going to be good or very good. We don't know about that, because since the weights are randomly initialized, this can happen. And the third experiment is we're going to add another layer of con and pool D. So we're going to do 3 training definitions in the same experiment. All right, let's get started. So we're going to go to the model flow here and click on new flow. So we're going to get started with the default architecture, so you get a baseline, and it's just a way to reduce the errors. Since there are so many parameters, it's very easy to make a mistake. Okay, so I'm going to go to my from example here and then simply choose the single convolution layer on MNIST and say create. All right, there you go. So the first one is we are going to get the image data all set up with the source. Since I recreated this, so I'll have to do this again. If you already have your existing project, then you don't have to do this. This setting will already be there. Okay, so MNIST train test, MNIST test and validation. It's MNIST validation. All right, so go to settings and make sure everything is okay. Yes, looks fine. And the epochs, we're gonna keep it at 10. That's good. I'm going to remove the con and value and pool layer, and I'm simply going to connect directly to the flatten layer. And I'm not going to change anything. I'm going to keep the learning rate and everything as is. Now this will become our first training definition. So simply publish it. So you have to give it a unique name. So I'm going to say MAA1 and publish. So there you go. This training definition is being created as we speak. All right, it's good to go. It's created. So now we are not going to create an experiment so soon. We're going to wait till we create all the training definitions, and then we will go to the experiment section. All right. So we're now going to increase the epochs for the second training definition. So all I'm going to do is simply say Control Z, and you should get back your components. Obviously, you can bring in the components from here as well. Okay, so let's double check here and let's go to image data. Here I'm coming here to increase the epochs. As you can see, this is 10, and for second training definition we need 30. Everything else remains the same. So con D, value, pool D, all of them remain the same. However, we can give it a quick look. So 64,331, and pool D is 2222 and 2. All right, good. Most importantly, double check on the learning rate, because this does make a big impact on the result. Okay, so all good. So this is your second training definition. So go ahead and publish this. I'm going to call this MA2 and say publish. There you go. That's it. So this is your second training definition. So now for the third training definition, we're going to keep everything as is, but we're going to increase the convolutional and pooling layer. All right. So what we're going to do now is we're going to remove this connection. You're going to basically shift and copy these. So there is a way to copy here. So as you can see here, this is copy, and select and then you simply paste it back. So this is one of the another cool features of the Watson Studio. Right, so there you go. You connect your pooling back to Conde, and you collect your pool back to your flatten. So everything looks good, everything checks out as you can see here. Of course, it's helpful to change the number of filters, the size, and also in the pooling layer, you can change the stride, you can change the filter size. But let's try to take it one step at a time, and let's try to go with this so that we can compare in a way which is reasonable. All right, let's go and publish this, and definitely I want to check the learning rate. The learning rate looks good, so we're gonna say MAA3. All right, so say publish. All right, so now we have 3 training definitions, so we can go ahead and create the experiment and run them in that experiment. So I'm going to say train it in an experiment and give it a name. So we're going to call it MAA EXP, and of course this is the same procedure which you did earlier. So choose any connection you like. You can have multiple connections. So this is for your source data, where you have your source data, and this one is for storing the results. All right, there you go. So pretty good. So associate your training definition now. So we're gonna go to the existing training definition, and we're gonna choose MAA1. So there you go, and choose the processor. We're not going to use any hyperparameter, and say create and run. So sit back and relax. It's going to take a few minutes and the numbers will start coming in. I'll get back to you in just a few. Okay, so we're back and we can see that the numbers have started coming in. So it's not bad, it's 0.7. So I can go back inside the run and take a look at the accuracy. So this is the validation accuracy. That's what we want to know. And as you can see, it's right about 0.7ish. So it started off pretty good. So the weight initialization was pretty good. So this time this run might have got good starting weights. All right, let's go back to the experiment. So this is almost complete. So let's go and add the next training run. So go back and choose your training definition. As you can see, we can't find MAA2, so that's okay. That means that we have missed out on saving it properly. All right, no problem. We can go back and create it. All right, so let's cancel this. So this is a good opportunity to see how to kind of recoup after you have such an incident. So I'm going to go back to my flow. We're going to make those changes and save training definition. Okay, no problem. So click on your project and let's pull up your flow right about here. And the second training definition which we wanted to create was basically the plain vanilla one with just more epochs. So what I'm going to do is I'm going to delete the additional conblay here simply, and you're going to fix your pool with your flatten, and just make sure that you do have the epochs correctly set. There you go, 30. That's what we want. And of course I would definitely want to check the learning rate again, and there you go. All right, let's go ahead and save this. Say publish, and I'm going to say MA2 and say publish, and let's give it a second. There you go. So now it looks good. So now what we're going to do is we're going to go back to your project, and we're going to go back to your assets, right? And we're going to pick up your experiment. So that's how you do this. Go back to your experiment. So we want to add the training definition to the same experiment so that we can compare it. So there you go. So we're going to open the experiment. Okay. So add your training run, and we're going to go back to existing training definition and simply try to find MAA2. All right, there you go. Pretty good. So go for add and create and run happens automatically sometimes. So when you add it, it kind of takes it by default. Sometimes it adds and asks you for a create and run. Either way, you gotta wait for a little bit. So I'll get back to you in just a few. Okay, so the results are coming in, and as you can see, this is pretty good. The validation accuracy is 0.979 and the training accuracy is 0.996. Pretty good. Let's take a quick look at this, how this performed. And as you can see, the loss is here. This is the accuracy. So accuracy started about 0.6, and then in a few iterations it jumped to 0.9 and kind of stayed there pretty much. So if you want to see the fine print, you can actually go to the logs and take a look at the logs. So this is the last 500. So you may not get to see all the epochs. So this is the 19th epoch here. And as you can see, this is starting to get closer to where we are once we're done. All right, now let's add the final experiment. So this is almost done now. So let's go and say add training run. The procedure is exactly the same. Existing definitions, and this time we're going to add the MA3, and we're going to use the same hardware, of course. Say add, and if this allows you to create and run, then run, otherwise you're fine. So just give it a few and we'll get back to it. We have an error. It says an error occurred retrieving experiment information. So this is nothing from our side. This is from the infrastructure side. All right, so what we're going to do is we are going to create another experiment. So go back to your project. So these are the issues which you might face while you're using IBM Watson, and always it's good to know what to do next. All right, so your experiment may be frozen. So as you can see, it may not open up as it has an error. We do know what the accuracy was from the previous training definition runs. So this time we're just going to create an experiment here. So let's say new experiment and just run the last one. All right, so I'm going to call this MAEXP2, and you're going to do the exact same thing. All right, and there you go. And add your training. So we're interested in running MAA3. So there you go. All right, so create and run, and let's see how this pans out. This is the one with 2 convolutional layers. So give it some time. I'll get back to you in a few. So the experiment has started and is being queued as of now, and then eventually it's going to get to progress. So just wait a little bit longer. Alright, the training is complete, and if I take a look at the accuracy, it's pretty good. It's 997 and the validation is 988. Pretty good. The loss is also very less. And let's go take a look at the logs. So as you can see, right on the first iteration, in fact, it kind of reduced to a pretty low loss here. So this is the validation accuracy, which is pretty good. And let's take a look at the training accuracy, which is right about here. And this also has, of course, this is the mirror image of the loss. So therefore, right on the first iteration, it kind of hit a nice 0.9, and then it kind of increased after that, or almost remained there. So to see the fine print, we got to go to the logs and take a look from there. So this is 0.996, and so there could be some small improvement, which is also very significant. And here on the 27th epoch, and then you see that the accuracy is increasing, so it becomes 0.99. So there you go. You can do your own analysis from this point as to what happened. All right, great, really good.